Action.
Hello guys, you're welcome back to Sensory Academy, the number one spot for WAEC and JAM success. Now, today I'm bringing to you alternative to what's practical in chemistry. As you have to know that what our chemistry practical is coming up in some days, like 3 days to what now, and we notice that a lot of students are panicking about the kind of question that we said because this is our first experience with WAEC GCE Alternative to what practical. So according to what WAEC, there are 3 different questions that will be what's given to you in WAEC, and this question WAEC is going to be testing your knowledge on 3 things, 3 aspects of chemistry. One of it is the qualitative analysis, and the second one is the quantitative analysis. Why the third aspect of chemistry that your knowledge will be tested on is SWOT analysis. Now I'm going to be analyzing each of these aspects for you one after the other. Why? Because I've already giving out 3 different questions, likely questions that may come out in this year's GCE WAEC chemistry. Now, so these are my questions. I'll be starting my question today with qualitative analysis, which is the question 1. Now, GCE questions are going to be looking exactly like this. They're going to set the question for you like this, whereby you are going to be having the observation and you'll be expected to write the inference, unlike your WAEC practical. In WAEC, each of the apparatus are provided for you, and you are asked to perform the experiment. So from the experiment you perform, you are going to be finding the observation. Then from your observation, you are going to be looking for your inference. But in GCE, this experiment has been done, so you don't need to perform the experiment. All you need to do is that just find the inference to each of the observation that is given to you. So your observation will be given. They just want you to know, maybe you have the knowledge of inference. What do I mean by inference? When we say inference, inference simply means the kinds of anion that is present in each of these observation. That is the word inference. All together. Now let's start with the question that is given to us. Now they said you are provided with 2 unknown salts A and B. Carry out the following test and record the observation and inference. Now the first test said to 2 cm³ of solution A, add sodium hydroxide in drops, then in excess. Now whenever they give you 2 things that you should add in drop and in excess, in drop is just to know the kind of anion that is there, and in excess is to show to confirm the anion that is present. That okay, this anion is present in this observation. Now the second experiment, they said to another 2 cm³ of A, add ammonia solution in drops and in excess. Now in addition of ammonia solution in drop and in excess, want to test run this same solution A with different solution. The first solution is using sodium hydroxide, and the second solution is using ammonia. Now the third question said to 2 cm³ of solution B, add barium chloride solution, then add HCl. Then the fourth question said to another portion of B, add silver nitrate, then add dilute HNO3. The following observations are recorded. Write out the inference. Now these are the observations of the experiment that is given. Now as you also know that you're only looking for the inference of this experiment. Now you might be giving something like this for you, whereby they are going to be putting dash on each of the experiment just for you to find the inference. Now let's take a look at this one after the other. When sodium hydroxide solution is added to A, actually we might not have we don't know the solution A itself, we don't know it, but they told us that a blue PPT is formed, and that blue PPT remain insoluble in excess. Now which of the following anions always give blue precipitates when in which of the following anion always give a blue precipitate? Now you see, whenever you are given a blue precipitate in an observation, the major anion that normally gives a blue precipitate is copper anion, copper 2 anion. Copper 2 anion always give a blue precipitate in a solution. So from this place, they say sodium hydroxide solution A gives a blue precipitate that remain insoluble in excess. Now when they add in drop, when they add 2 cm³ of solution A in drop, it gave rise to a blue precipitate. Now they add excess of 2 cm³ of solution A. They notice that it is insoluble. That means the blue precipitate is insoluble. That means there is more of the blue precipitate when they add it in excess. So we can easily say that copper 2 anion is confirmed from this place here. Now, if you now take a look at solution A, by addition of ammonia to solution A, if ammonia is added to solution A, they notice that they gave us that it gives what? A light blue PPT in drop and deep blue in SS. Now, when light blue PPT is formed in drop, it showcases likewise. Hello, listen. So far, it is still blue precipitate. It is still denoting that what? That solution A still contain copper 2 ion. Altogether. So when we now what? Testron it by adding excess of ammonia to solution A, we notice that what? They gave us that it produced a deep blue precipitate. Now this deep blue precipitate denotes that what? That copper 2 ion is truly what? Confirmed. Now what is now the observation of this solution A? From this solution A, it simply shows that what? Solution A contains a salt of what? Copper. Altogether, it contains a what? A salt of what? Copper. Because both from the experiment showcase that what? Copper 2 ion is present. So it contains a salt of copper. Now, the next one is now the question 3. They said when barium chloride is added to the solution. Now, which solution? Don't forget that we have two solutions here. Solution A and B. Now, when barium chloride is added to solution B, then they added dilute HCl to that solution. That means we have what? Barium chloride plus dilute HCl, then plus what? Solution A. Then what did they see? We notice that there is a white PPT that is formed. White precipitate is formed. Now, when there is a formation of white precipitates, and they said that this white precipitate remain insoluble. Altogether, now take note of something else. Now, they are trying to what? Experiment it using barium chloride at the same time using silver nitrate. Now, when they use barium chloride, they notice that what? It produces a white precipitate. Now, this white precipitate denotes that there are two different ions that might be present in it. Now, what are the ions that are what? Present? We can have the formation of what? Sulfate ion, and also formation of what? Chloride ion. These two ions usually produce a white PPT in a solution altogether. So whenever you have a white precipitate, it denotes what? Presence of sulfate ion and what? Cl ion. How do you answer the question? You just answer by writing that what? Sulfate and SO42 plus, SO42 minus and Cl minus is present from the solution. Then the second thing, when we now add silver nitrate plus dilute HNO3 plus solution B, they said it still produce what? White precipitate, which remain in the solution. Now, if after the what? Testing it with silver nitrate, white PPT still remain in the solution, it showcases that what? Chloride ion is fully present. Is what? Fully present in the solution. Altogether like that, chloride ion is what? Fully present in the solution. Now, what is now the deduction from this inference? As I said here, the deduction in this inference denotes that what? There is a what? Presence of salt of copper 2 in what? In the solution. Now, what about in this place here? It showcases that what? There is a mixture of two salts. Salt of chloride and salt of what? Sulfate. Both of them are what? Are present in this what? Experiment. Now, for those of you that what? Might be what? Wondering, how did I get each of these? Now, I'll be dropping a link of my video below. My video under what? Qualitative analysis. How you can easily analyze each of the ion given from the what? Observation given to you. Starting with the question 2. Now, I shall also what? Understand that what? The question 2 will fully be on quantitative analysis altogether. Now, this is the question on what? Quantitative analysis, whereby I want to test on acid and base, the test of acid and base. Now, we are given a solution of HCl contains X mole per dm cube of an acid, 25 centimeter cube of this solution neutralized 25 centimeter cube of 0.1 mole conc of sodium thiocarbonate. Now, take note of something that was, assuming you are performing these experiments, don't forget that what? In the lab, you're going to be given different apparatus for performing the what? Experiment altogether, like your burettes, then your conical flask and the like, just to take what? Carried out this what? Experiment. But in GCE, you don't need to carry out any experiment. The experiment has been carried out for you. All you need to do is just to calculate. Like for example, we want to calculate the titer value. What do you mean by titer value? That is the amount of, or let me say the volume of acid that is used in the experiment. You want to calculate the volume of acid that is used in the experiment. Sometimes it might not ask you to calculate the volume of acid that is used. Unlike this one here now, they've given us the volume of acid that is used and the volume of base. The only thing we want to know is that they want us to find the concentration of the acid that is used in that experiment. Now let's follow on. Now you are given the concentration of the base as 0.1 mole conc, which is sodium tricarbonate. Now say calculate the concentration of HCl solution in mole per dm cube. How do I find the concentration of HCl solution in a mole per dm cube? There are two ways of doing this experiment, and how do we do it? This is how we go about it. Now don't forget that we have the first thing that you need to do when it comes to titration is you need to balance the equation. Now what is the equation given to us here? We have hydrogen chloride, HCl, hydrochloric acid, plus reacted with sodium triazocarbonate. When HCl reacted with sodium triazocarbonate, we are going to be having the reaction that we're going to be having is we are going to be having NaCl plus H2O plus CO2. Now this CO2 will be given off as as a gas in the experiment. Now we are going to try to balance up this equation. Now when you balance up the equation to know the amount of acid that is used and the amount of base that is used. Now from this point here now, I have my Cl, my Na, sodium here, balance the metal. Sodium here is 2. Now I need to balance the sodium by putting 2 here. Now if I put 2 here, then sodium will be 2 and chlorine will also be 2. Then from here, add 2 to this so that I'll be having 2 chloride, 2 hydrogen, which is balanced with 2 hydrogen here. And my oxygen is 3 here, and cross-checking here is also 3 oxygen. Now, this is the balance equation. Now, number of mole of acid that is used in this experiment is 2 mole of acid. Number of mole of base that is used in the experiment is 1 mole of the base is used in experiment. Now, from here, we are given the concentration of the acid that is used. Why the question asks us to calculate for the concentration of the base that is used? Now, there is one formula that you can usually use that will make your work easier and faster without stressing yourself. Now, what is the formula? By using CAVA over CBVB, which is equal to number of acid, mole of acid used over number of mole of base that is used from the experiment. Now, how do we go about this? Now, where the Ca represents the concentration of the acid that is used, and Va is the volume of the acid used. Now, take note of something. Now, the volume of the acid, or let me say the volume of the acid or the base, must always be in dm cube. That means decimeter cube, dm cube. Now, but the question given to us, they gave us the volume of the acid in centimeter cube. The first step that I need to do is to convert the volume to dm cube. Now, how do we do that? We are going to be dividing the volume. Let me say the volume of the acid is 25 centimeter cube, which is going to give us 25 divided by 1000. Now, if I divide the volume by 1000, what am I going to be having? I'm going to be having 0.0025. I think 0.0025. That's what I'm going to be having. Let me try divided by 1000. So I'm going to be having 0.025, sorry, 0.025 dm cube. That is the volume of the acid. While the volume of the base is also the same. Vb is equal to 25 centimeter cube, which is going to give us 0.025 dm cube. Now, after getting the volume of the acid and the volume of the base, what is the next thing? The next thing is for you to calculate for the concentration of the acid given, whereby we know that the concentration of the base given to us is 0.1 molar concentration. Now, how do we now get the concentration of the acid? From here, substitute each of your value. I'm given my Ca is unknown, my Cb is 0.1 molar conc, and my Va is equal to my Vb, which is equal to 0.025 dm cube. Altogether, now, what is my Na? From the experiment, from the equation that you balance, my Na is number of mole of the acid, which is equal to 2. My Nb is number of mole of the base, which is equal to 1. So I'll be having my Na as 2, my Nb as 1. Now, if I put in this equation, I'll be having Ca, my Ca, I don't know, times my Va. What is my Va? 0.025 over my Cb, which is 0.1, times my Vb, which is 0.025. So now equals to number of mole of the acid that is used is 2. Number of mole of the base that is used is 1. So if I cross multiply this, I'll be having 0.025 Ca all over. This should give rise to 0.0025. If I'm not wrong, let me multiply times 0.1. I'll be having 0.0025, yeah, which is equals to 2 over 1. Now we can easily cross multiply this. If I cross multiply this, I'll be having 0.025 Ca equals to 2 times 0.0025. Now, multiplying this, 2 times 0.0025 will be giving rise to 0.005. Yeah, 0.005 times 2. That is 0.005. Yeah, 0.005. 0.025 Ca. Now, my Ca will now be equals to 0.005 divided by 0.025, which should give me the concentration of the acid divided by 0.025. Then I'll be having 0.2 mole per dm cube. Now, question A has been done. Calculate the concentration of the acid that is used, which is what I just calculated in this video. Now, the second part of it is about how many moles of HCl are in 250 centimeter cube of the acid. Now, in this case here, I want us to calculate the mole of HCl that is found in 250 centimeter cube. That means if the volume is no more 25 and the volume is now 250 centimeter cube, what will I do? The second thing I need to do here is find the volume in dm cube. 250 centimeter cube in dm cube will give rise to 0.25 dm cube. Why? By dividing this by 1000. So I'll be having 0.25 dm cube. Now, after dividing this, now we are going to be applying this formula to get mole. Mole of a substance, molar concentration, conc, is always equal to what? Mole, number of mole over the volume, the mole over the volume. Or let me say, molar concentration is equal to mole over the volume. Now, we are asked to calculate for how many moles of HCl that is there. So, and we know that the molar concentration of HCl is 0.2 mole per dm cube, and the volume given to us in this case is 0.25 dm cube. So let's substitute everything. I'll be having 0.2 equals to number of mole over the volume 0.25. Now if I cross multiply, I'll be having what? Mole to be equal to 0.2 times 0.25. That should be equal to 0.05, if I'm not wrong, 0.05 mole. So the number of mole of the acid, which is in B, is equal to 0.05 mole. Now, question C, here said, states the indicator used and the color change at the end point. Now, this is another point that I need to take note of altogether. Now, in any experiments, we are going to be given the different indicators altogether like that. Now, in this experiment that is here, in this experiment of neutralization of the HCl and sodium tricarbonate, indicator that is always used in this experiment is melty orange. Altogether. And what is, because here they are asking to say the color changes. How does the color changes? Melty orange changes in acid. In acid, melty orange is always red in acid. Altogether, now when we pour melty orange in acid, it always gives rise to what? A red color. Then it automatically changes its color from red to yellow in a base. Altogether. Now at the end point, because they say we should what? At the end point, what will be the color at the end point also? These are the changes that occur. But at the end point, the color changes finally to orange at the endpoints. It changes finally to what? Orange at the what? Endpoint. Now this is all about what? The question 2 that we just predicted. Likely question that was it will be coming out. So I'll be moving on to what? Question 3. So let's jump to question 3. Question 3 on preparation of salts. So in this question now, they are going to be giving you a question whereby they are going to ask you to describe how a salt is being what prepared. Now take note of something that was. It is going to be based on what you've been doing. The question 1, which is the qualitative analysis, what is all about. That was what the salt is going to be all about. Now look at this question. It said describe how you would prepare pure dry copper 2 sulfate crystal from copper 2 oxide. Include the apparatus used, steps and observation and equation. Now I've itemized all those steps that are required in preparing this salt. Now the first step that you need to do when preparing a salt is what? You are going to add a dilute H2SO4 into a beaker. A dilute H2SO4 will be added to a beaker. That is the first step. Now the second step is that you are going to add a solid copper oxide in small portion while stirring until no more dissolves. That means all the acid has been reacted. Now listen. Now you are going to add a dilute you are going to add copper oxide solid in small portion. Are you getting what I'm saying now? Now you are going to stir it until no more will be dissolved. Are you getting what I'm saying now? No more will dissolve. Now if there is nothing that is dissolved again, it simply means that the acid has completely reacted with the solid copper oxide. Now the third step is that you are going to filter to remove the excess black copper oxide. Now you see, when there is an excess copper oxide in it, the next step is for you to filter it. Filter so that the excess black copper oxide will be removed. That is step 3. Then step 4, what do you need to do? We need to gently evaporate the filtrate to concentrate it. All together, we are going to evaporate the filtrate so that it can be concentrated. Now, the step 5 is that we are going to leave it to cool and crystallize. All together, that's the step. You need to follow all these steps so that you can get your full marks. Now the step 6 is the dry crystal between filter papers. Dry the crystals. You are going to dry the crystals between the filter papers altogether. Now that is the steps that is required in preparing sort of copper 2 sulfates altogether. Now the next thing that they say you should write the equation. Since it is a reaction of copper 2 sulfate and the acid H2SO4 that is given to us here altogether, what are you going to do? Now, when copper reacted with H2SO4, it provides, reaction between a base. Copper oxide is a base. H2SO4 is an acid. When an acid reacted with a base, what happened? It produced a salt and water. So, copper 2 sulfate salt is produced and plus water. Now, this salt that is produced from the observation of what we got, it simply shows that a blue crystal forms on column. It forms a blue crystal. Now that blue crystal showcases the color of copper 2 sulfate. Now, what does this thing? I said it showcases the color of copper 2 sulfate. That is the inference that you are required to write in this experiment here. They say give the inference of the experiment. Now, the inference showcases that there is pure copper 2 sulfate crystal is obtained from the preparation of the salt. Thanks for watching the video. Make sure you subscribe and drop a like. Share the video with your friends that are also writing this GCE. And don't forget, try to like the video and